Page 5 of Counting and Binomial Expansion Addendum. Today we're going to talk about combinations. You're going to see why we are talking about combinations the section after we talked about permutations, because combinations are actually something that is derived from permutations. Remember that permutations is basically every way you can take a certain number of objects out of a group of objects and put them in different orders. And a combination is kind of like that, except it's all the different ways you can take a certain amount of objects out of a group of objects, but without worrying about the order. So let's show how those two are related. So a combination is a selection of objects without regard to order. According to the reading, how many different teams of 3 people can be selected from 5 people? So if you look at the page 254 reading, you will see that there are actually 10 ways to select 3 people from a group of 5. So like if you say that the 5 people are named A, B, C, D, E, then like for example, one way to select 3 people out of A, B, C, D, E is A, B, C. Another way would be like A, B, E. Okay. Now, what about like ABC and CAB? Are those two different combinations? No, they're not, because ABC and CAB are the same 3 people taken out. And when you're talking about combinations, different than permutations, you don't care about the order that you drew them or the order that you're ordering the people in a row. So that is why there's a lot less combinations than there are permutations. Okay, so remember that if you were going to calculate the number of permutations of 3 people chosen from a group of 5, you would do 5 times 4 times 3, which is 60. And look how the number of combinations of 3 people drawn from 5 people is 10. So why is it 6 times bigger, the number of permutations compared to the number of combinations? And actually the reason why is because let's say that you do have person A, person B, and person C chosen out of a group of 5 people. How many different ways are there of ordering the 3 people A, B, C? And remember that to figure out how many ways you can order 3 people, you could just do 3 times 2 times 1, because the first position you could put any of the 3 people. Once you place the first person, you have 2 left to choose from, and finally you have 1 left to choose from for the last position. And if you multiply those 3 numbers together, 3 times 2 times 1, it gives you 6. There are 6 ways to order the letters A, B, and C in 3 different positions. So since every time you draw 3 different people out of the group of 5, there's 6 ways to order those people. There's going to be 6 times as many permutations as are combinations, since combinations order doesn't matter, right? So to find the group of combinations, what you can do is you find the number of permutations, and then you divide the number of permutations by all the different ways you can order the 3 people, for example. Okay? So basically, number of ways to order 3 people equals 6. So we always divide by 6. Okay. Remember that the way that you find the number of permutations is you do n factorial divided by n minus r factorial. Okay, which is basically like if I was going to choose 3 people out of 5 people, I would say that that would be equal to 5 times 4 times 3. Remember that? So 5 times 4 times 3 is basically equal to 5 factorial over 2 factorial, right? N factorial divided by n minus r factorial, where r is 3. Okay. Now, if I want to figure out what the number of combinations are, then I would divide the number of permutations by the number of ways I can order R items. And that is why the expression for combinations looks like that with the additional blue R factorial in the denominator. Okay? All right, and there is, of course, a calculator function to do that under math probability. It's the third function here, NCR. Okay, but a lot of times we can do these combinations by hand, even though it looks kind of like you do multiplications that are too big to do by hand. Actually, there's a lot of canceling out that happens, and I'll show you how to do that on some of these problems. Number 1, list the different teams of 4 that can be chosen from a squad of 6. So we have 6 people, A, B, C, D, E, F, and we want to draw 4 people at a time. And let's see how many different combinations of 4 can be made from a group of 6. For example, A, B, C, D is one possible group of 4. A, B, C, E, A, B, C, F, etc. Right? So the way we're going to calculate that is we're going to first find the number of permutations of 4 people drawn from 6. And we can do that by saying, okay, we have 4 possible positions. The first position can be filled by 6 different people, the next one by 5, the next one by 4, the next one by 3. That gives us the number of permutations. Then we divide by the number of ways the 4 people could be arranged, which would be 4 factorial. Okay? And now I'm going to show you how this is not as bad of a multiplication as you might think. First, I'm going to break the 4 factorial into 4 times 3 times 2 times 1. And then once you make this fraction, you can see that there's a lot of canceling that goes on here. Look, I've reduced this to 3 times 5, actually, right? So the number of different teams of 4 that can be chosen from a squad of 6 is actually just 15. I can verify that number with the calculator by doing 6 chooses 4. The way you read the expression n and r in parentheses, or sometimes it's written like this with a small n and r next to the c, is the way you read that is 6 chooses 4. So 6 chooses 4 yields 15 on the calculator too. Number 3, candidates for an examination are required to answer 5 questions out of 9. In how many ways can the questions be chosen if there are no restrictions? If question 1 was made compulsory, how many selections would be possible? So 5 questions out of 9, we don't care about the order that we do the questions, so this is a combinations problem. So basically what we're doing is we're doing 9 chooses 5, and 9 chooses 5 would basically be 9 factorial divided by 4 factorial. Like that. And it would also be divided by 5 factorial. And so if we can do a lot of canceling here, you can see that the multiplication is not so bad. It's just 7 times 9, which is 63, and 63 times 2, which is 126. We can do that in our head. Okay, so that's how many ways 5 questions could be chosen out of 9. And then for part B, it said, what if question 1 was compulsory? So in that case, you have 9 questions to choose from, but the first slot is already filled with number 1, and then you only have 4 other slots to fill. So instead of being the problem 9 chooses 4, we're choosing out of 8 questions, and we're only choosing 4 questions. So our problem, instead of 9 chooses 4, becomes 8 chooses 4, right? Instead of 9 chooses 5, it's 8 chooses 4. So 8 chooses 4 is 8 times 6, 8 times 6, or 7 times 6 times 5 divided by 4 times 3 times 2 times 1, because it's n factorial divided by n minus 1, r factorial, which is 8 factorial divided by 4 factorial, divided by r factorial, which is also 4 factorial. So we can cancel out a lot here too, and we end up with 5 times 7, which is 35, times 2, which is 70. How many different teams of 5 can be selected from a squad of 12? This is a pretty straightforward one. Basically, it's 12 chooses 5. So 12 chooses 5 is 12 times 11 times 10 times 9 times 8 times, 12 times 11 times 10 times 9 times 8. That would be 5 positions of chosen out of 12. And then on the bottom, you would also have r factorial. So it would be 5 times 4 times 3 times 2 times 1. And let's cancel some numbers out here. Okay, so we canceled everything on the bottom. We're left with 12 times 11 times 3 times 2. So basically that's 12 times 66. Maybe we need the calculator to do that. 792. And let's just check that using math probability and choose R. So let's put 12. Oops. Math. And 12 chooses 5. Okay, all right. Part B, how many of these teams contain the captain and the vice captain, or exactly one of the captain or the vice captain? Okay, so let's figure out how many ways you can choose a team of 5 from a squad of 12 and have the captain and the vice captain chosen as part of the team. In this case, basically what they're asking is how do you fill the last 3 spots, right? Because the first 2 spots are taken by the captain and the vice captain. There's only one combination of ways to fill those 2 spots with the captain and the vice captain because it's 2 spots and 2 people. What about the remaining 3 spots? How many people are you drawing from there? Well, there's 10 people that are not the captain and vice captain. So basically here what we're looking for is 10 chooses 3, because the first 2 spots are filled by captain and vice captain, and the last 3 spots are what you want to try to fill. So basically that would be 10 times 9 times 8 divided by 3 times 2 times 1. So the 3 would cancel out with that, and the 2 would cancel out with that. We're left with maybe 40 times 3, which is 120. Okay, what about exactly one of the captain or the vice captain? So in this case, we either have the captain or the vice captain in one of the spots. The remaining 4 spots would be filled by the other 10 team members. So it would be 10 chooses 4, right? 10 chooses 4 would be 10 times 9 times 8 times 7 divided by 4 times 3 times 2 times 1. And we could cancel out the 8, and we could cancel out one of the 3's from the 9. And so we're left with 210 for 10 chooses 4. Now remember, one of the slots could be either the captain or the vice captain. So there would be 210 combinations with the captain, or there would be 210 combinations with the vice captain. So actually, total, there would be 420 total combinations with either the captain or the vice captain. And that's it for page